Converting fractions to decimals and decimals to fractions. You'll learn this in Module 11. To convert a fraction to a decimal, all you have to do is just divide the numerator by the denominator because fractions indicate division. You learn that in Module 1. Here we have a fraction 1/16. 1 divided by 16 equals 0.0625. This is a ratio. It is also the decimal equivalent of the fraction 1/16. 1/8, 1 divided by 8 equals 0.125. 1/4 equals 1 divided by 4 equals 0.25, and 1 divided by 2 equals 0.5. These fractions above are all found on a ruler. Other examples: 1/3 equals 0.3. This line over it indicates that that 3 goes on and on forever. The 3 with a line over it, bar 3, with a line above indicates that 0.3 goes on repeating forever. We can also say 0.3333 ... That also means that it goes on forever. 5/6, we get 0.8. It terminates at 8, and the bar 3, the 3 goes on forever. Here we have 1 divided by the square root of 3, which is 0.577350269. This keeps going on and on forever. It produces a fraction that neither repeats, never terminates, and goes on forever. There are 4 types of decimal fractions: terminating fractions, repeating fractions, terminating repeating fractions, and irrational fractions. The example we just left on 1 divided by the square root of 3 is basically an irrational fraction. Terminating decimal fractions terminate after a fixed number of decimal places. Fractions found on a ruler all have terminating, are all of the terminating type. For example, 1/16, that terminates 0.0625. That's it after 4 decimal places. 1/8 is 0.125. It terminates after 3 decimal places. 1/4 terminates after 2 decimal places. 1/2 terminates after 1 decimal places. The fractions on a ruler with denominators of 16 will terminate after 4 decimal places. The fractions with denominators of 8 will terminate after 3 decimal places. The fractions with a denominator of 4 will terminate after 2 decimal places, and the fractions with a denominator of 2 finally will terminate after 1 decimal place. Examples of repeating fractions: 1 divided by 3 equals bar 3, point bar 3. The 3 goes on forever. 7/99 equals 0.07 bar 0.07. So it's going to go 0.7, 0.07, 07, 07, on and on forever. 41 3/33 is going to equal 0.1 bar 123, 123, 123. 3/22 over 9/99 is going to give us 0.322 bar 322, goes on forever. Repeating fractions can repeat in tenths, thousands, hundreds, or any number of places. For example, point bar 3 repeats in tenths. Point bar 07 repeats in hundreds. And then point bar 123 repeats in thousands. And then finally 10 thousandths on the bar 0.0322. A terminating repeating fraction is one that has a beginning that terminates and followed by a repeating digits. For example, 5/6 is an example. It gives us 0.8 terminating, but the 3, bar 3, that 3 goes on and on forever. 19/45 equals 0.4 bar 2, the 2's go on forever. And here 1/13 4/50 equals 0.25 terminates at 25, but 1 bar 1, that 1 goes on and on forever. An irrational decimal fraction is one that where the digits do not terminate, repeat, or terminate, repeat, but continue forever without any pattern. Pi over 1 is an example. 3.1415 just keeps going on without ever making a pattern, repeating, terminating, or whatever. Square root of 2 divided by 1. Square root of 3 divided by 1. 12th root of 2 divided by 1. This is important in music. This is how we separate music notes, by the 12th root of 2. Decimals, by the way, can be converted to fractions. However, each type of fractions requires a separate method. We learned how to take a fraction and make it to a decimal, but now we want to learn how to take a decimal and convert it to a fraction. Converting terminating decimals to fractions is fairly easy. In this case, we have 0.5 equals some number. Move the decimal place until you get a whole number. Okay, so we get 5, and then we're going to divide it by the number of places of the decimal. 0.5 is in tenths, so we're going to say 5/10. We reduce it, it becomes 1/2. Here's another example, 0.25. We're going to put the 25, we're going to multiply by 100 to get 25 to be a whole number, and we're going to divide it by that 100. So 25 over 100 equals 1/4. 1/4 is 0.25. Here we have 1.125. We're going to multiply by 1,000 to get a whole number of 125. Divided by 1,000 is going to equal 1/8. And here we have 0.0625. We're going to multiply by 10,000 rather. We get 625, and we're going to divide it by that 10,000, and we will get 1/16. Repeating decimals can be converted to a fraction by the following method. We have point bar 3, that 3 goes on and on forever. The 3 represents tenths. So study the table on the next page, but then we'll show you a simpler method to do it. I have to show you the formal way first. Here we have let n equals 0.3, okay? And it repeats in tenths. So we're going to say 10n is going to equal 3.333. That 3 goes on forever. The reason that we got 10 is because we multiplied this. That becomes the whole number, 3.3. We're going to subtract 1n from 10n, and we're going to get minus 0.3 subtracted from 3.3, and we're going to be left with 9n. 10n minus 1n equals 9n. 3.3 from minus 0.33333 is going to give us 3. And then we want n to stand alone, so it's going to be n equals 3 over 9 equals 1/3. And that's the answer. Here's another example. N equals 0.25. This is in hundreds. So we're going to have 100n equals 25.25252525. We're going to subtract 1n from that, and we get 99n. 25.252525 minus 0.252525. What we're doing is we're canceling out the fractional portion, and we're left with 99n equals 25. We divide, we get n to stand alone, and it's 25 over 99, and that's our fraction. In this case, this is in thousands. So we're going to multiply 1,000 times 0.123123, and we will get a whole number, 123.123 bar, which goes on forever. We're going to subtract 1n, or the fraction, from this number. So we have 123.123 minus the fractional portion, that cancels out, and we're left with a whole number, 1, 2, 3, and we have 99n, 1000n minus 1n gives us 99n. We want n to stand alone, so it becomes 123 over 99,999, which will reduce to 41,333. And if we divide 41,333, we will get back to that number. Converting repeating decimals to fractions continues. Move decimal point to get the whole number to equal the numerator. 0.2, all we have to do here is go move the decimal point to get this to a whole number, and then we moved it in tenths, so we're going to put 19 under it. Here we're moving in hundredths, so we're going to move the decimal point 2 places. We have 1, we're going to put 99, 2 nines under it, and we will get 4/33. Here we have 3 places, 567 over 3 nines, 21/37. This is the simple method. Whenever you have a repeating fraction, just make it a whole number, whatever you have to do it, moving the decimal point, and you're going to put that number of nines underneath, and that will be your new fraction. Terminating repeating decimals such as 0.83 bar 3, the 3 goes on and on forever, can be converted into a fraction by the following method. The terminating portion is 0.8, terminates in tenths. So what we're going to do is we're going to say A equals 0.8. That's our terminating portion. And it terminated in tenths, so we're going to say 10A equals 8, right? So we have n equals 0.3. N is the fractional portion of 8 of that terminating part going on and on forever. Again, because it repeated in tenths, we have 10n equals 3.3. We have minus 1n equals minus 0.3, the fractional portion canceling out. We're left with 9n equals 3. N equals 3/9 equals 1/3. But that's still not the answer, because if you remember, we multiplied this 0.8 by 10. So we have 10a, okay, plus n over d times x. Basically, it's this. We have 8 and 1/3 equals 3 times 8 is 24, plus 1 is 25, divided by 3, and here's what we must always consider. Because we multiplied up here by 10, we're really dividing by 10 here. 3 times 10 is 30, so 25 over 30, and reduce becomes 5, 6. Review this video as many times as you need to until you understand this concept. Step 1. Converting, terminating, repeating decimals to fractions continue. Step 1. Notice the terminating part and how many digits it is. Tens, hundreds, thousands, etc. Step 2. Multiply by 1 plus the number of zeros, corresponding to the number of digits from step 1. Step 3 through 7, convert the repeating part to a fraction. Step 8, add to the whole number from step 2 and convert to an improper fraction. And then multiply the denominators by the same value used to get the terminating portion, and then reduce the fraction. Here's another example with a shortcut. Here we have 0.25, which is the terminating portion, over bar 2. The 2's go on forever. We're going to multiply by 100, and we get 25 point bar 2. Okay, and then all we have to do is, if you remember the repeating portion, because this is in tenths, all we have to do is put it over 9. So 25 and 2 nines converts to the improper fraction. And then finally, we're going to multiply the denominator here by 100, because we had to multiply by 100 up here. So it's going to be 227 over 9 times 100, which is 900. So it's going to be 227 over 900 equals 0.25 bar 2. 2 goes on and on forever. In theory, you can't get a fraction from an irrational decimal, however, because it goes on and on forever. But, however, you can approximate to a number of significant digits to attain a workable fraction. For example, pi is an irrational number as it goes on forever without terminating or repeating. If we choose 3.14 as a significant digit and close enough, then we can convert 0.14 to a fraction, use a terminating method, which would be 0.14 over 100. So we have 3 plus 14 over 100, and we have 3 times, it's going to come out to 3 7/50ths equals 157 over 50 equals 3.14. This we reduced right here. 3 plus 7 over 50. It was a reduced number. 3 times 50 is 150 plus 7 is 157 divided by this denominator. 50 is going to give us back to 3.14. That terminates Module 11. As always, review the video as many times as you have to until you understand the subject matter. And then finally click on the link below to take the online quiz and keep studying. If you have to go back over previous videos in this series, then make sure you do so.